Hi guys. So this is the third part of the GATE 2023 physics solutions. So let's start. So first is a question from electrostatics. So it has been given that there is a point charge plus Q and the energy is W1 is epsilon naught by 2 into E1 square dV. Now you know what is E1 here. It will be 1 by 4 pi epsilon naught and charge is 1, so it is 1 by R square. So this integration will take the value epsilon naught by 2 into 1 by 4 pi epsilon naught whole square and dv is 4 pi R square dr, right? From 0 to infinity. So it will be it's 1 by 2, 1 4 pi epsilon naught cancel out, 4 pi epsilon naught infinity at infinity and 0 to infinity it is sorry, there will be 1 by r to the 4 because of this r square whole square. It will be 1 dr by r square. So it is like half 1 by 8 pi epsilon naught 0 to, sorry, you can do the integration and find it to be minus 1 by r 0 to infinity. So at infinity it is 0, but at 0 it is not defined, so you can say it is infinity basically. So what you can do instead is take the limit r goes to 0, sorry, r goes to 0, 1 by 8 pi epsilon naught to 1 by r. Why we are doing like this? Because at the end we shall see that this will at the end cancel out. Okay, so let us find W2 now. W2 is given as the same energy but for the system when there is a concentric sphere. So I have not drawn this. It's like a sphere, so I don't know what it is, but you can understand from here. It is R1 and this is R2. So there is a charge Q here. So if there is a plus charge Q here, minus Q charge will be induced here, and plus Q charge again will be induced here. And you can use Gauss's law to find the electric field here will be. So here the electric will be. So let us just do the integration directly. Divided by 2 from the region 0 to R1. It is 1 by 4 pi epsilon naught whole square into 1 by r square into the this will be the electric r to the power 4, sorry, this will be electric field inside and 4 pi r square, this is the volume term. In between here the electric field is 0 because you can use Gauss's law and see there is no charge inside, net charge is 0 inside. So another integration will be from r2 to 0, sorry, it is r2 to infinity, and again it is like it is not by 2, 1 by 4 pi epsilon naught whole square 1 by r to the power 4 4 pi r square dr. Now what you can do is take epsilon naught by 2 again, sorry, so you can directly write it 1 by 8 pi epsilon naught but and here your limit becomes 1 by r1 minus 1 by r given at, right, at r is equal to 0, right? So this thing and this thing you can see that should cancel out. um Sorry, I did I do any mistake here because it is not cancelling out. So okay, sorry, I did a mistake here. So Yeah, so it is minus here and plus here, right? Because when you do the integration, the minus sign will come out. So it is minus here and plus here, and so now it's fine. Plus epsilon, so it is again to 1 by 8 pi epsilon naught, and it will be it will be so it is minus 1 by r, so it is minus 1 by r, so let's do it, r2 to infinity. So it will take the form 0 minus 1 by r2, it is only r2 into 1 by r2, right? So now you can say w, find w2 minus w1. This term will cancel out from this. This is basically w1, right? This term is w1. W1, so it will cancel out, and only thing that will remain is 1 by 8 pi epsilon naught into 1 by r2 minus 1 by r1. Now your 1 by 8 pi epsilon naught and r2 has been given as 1 by 2 minus r1 is 1, so 1, so it is minus 1 by 16 pi epsilon naught. So your, so in the question it tells me rather 8 pi by epsilon naught into w1 minus w2. So it is basically simply 1 by 8 pi by epsilon naught. So 8 pi by epsilon naught into 1 by 16 pi epsilon naught. So till now this pi cancels 8 to 2. So it is 1 by 2 epsilon naught squared, right? So this factor of epsilon naught squared is there is a problem. So I think so it's I feel because there is no dimensional match in this question. So this factor of epsilon naught should not be there. So I think rather than 8 pi by epsilon, it should be 8 pi epsilon naught into this one. Then the answer would come as 1 by 2 and your n will be 2 then. But here it is not the case. So I am not sure that how much the question is right. But if you think that there is a dimensional mismatch here, you can challenge this question and get marks. And if you think that I am doing somewhere wrong, please let me know also that. Okay, so let's move to the next question. So in the pion-nucleon scattering, one can come. So this for simple problem like pion goes to neutron. Sorry, pion scatters with some nucleon and wait. Sorry, there is some problem. Okay, pion scatters with the nucleons and produces a delta particle, whatever with the particle named delta. So what is the minimum energy of the pion for this reaction to occur? Okay, so what you can see, what is, let's use energy conservation in both the sides. It is e pi sorry e pi plus e n is equal to e delta. So it is to the power of p pi square p square c square plus m pi square c to the power 4 plus it has no it was at rest, so it will only have its rest mass energy root over of p delta square c square plus m delta square c to the power 4. And now you can take square of both the sides and find p pi square c square m pi square c to the power 4 plus 2 root this one, this quantity. Basically, it is the energy of this is the quantity that you want to measure, right? So let's write it E pi. E pi into mn c square plus mn square c to the power 4 plus p delta square c square plus delta square c to the power 4. Now, uh, the momentum at the start, before the reaction and after the reaction should also be conserved, right? What was the momentum before the reaction? It was p pi, because n did not have any momentum, right? And after it, the only momentum will have delta, so it will p delta. So momentum will be conserved. It is p pi is equal to p delta. It's a very pretty simple thing. So this you can write as p pi square c square plus m delta square c to the power 4. So this cancels out. Sorry, not this one. Sorry. I should not cancel it like this way. I should be a bit careful. So so nothing more cancels out. Okay. Now see what we get. What we finally get is sorry. Sorry. What we finally get is 2e pi into mn is equal to m delta square minus mn square minus m pi square by 2mn. Sorry, yeah, if you don't write it at here. So this is 2 e pi and sorry, this is e pi. So this is the energy of the um, pion that would be required. Now you can find, so because now everything has been given in the question. So your m delta has been given as 1230 MeV per c square minus mn has been given as 938 square, and your pi mass is minus 140 c square. Now and your 2 into mn is again it is c square, so whatever. So it is mn is again 140, right? Sorry, 938. So this will be the answer. So let's evaluate it. See what we get. 230 that's 938 in the numerator we get 613456, and in the denominator we get 1876. So the answer is 613456 by 1876, 327. 327.00, you can 0.0. So it is your answer, MEV C square. This is your answer. Okay. Now let's move to the next question. It's an electromagnetic wave has been given. It is that given that B is equal to B naught into some vector to the power I kz minus omega t. So what is the power passing through 1 meter square radius of circle's radius? So okay, so you can find this is a pointing vector which is defined as 1 by mu naught into E cross B, or when you are being usually you are perpendicular, so its magnitude only has been asked, and it will be direction will be only on the direction of propagation of the wave, so it will be on the z direction, and the magnitude of this will be 1 by mu naught to E into B, which is 1 by mu naught into B square C. And you know 1 by mu naught epsilon naught is equal to C square, right? So in the question only epsilon naught has been given, so mu naught is 1 by epsilon naught C square. So you can replace here and find answer is epsilon naught B square C cube, right? Now you can put the corresponding values here. That is 10 to the power minus 11 into B naught square, the minus 16, and C cube is 3 cube, that means 27 into 10 to the power 8 whole cube is 24, right? So it gives you 27 into 10 to the power 7 10 to the minus 3. Now it passes so this, what is pointing vector? Pointing vector is the energy per unit area per unit time, and you have been asked that is power per unit area, right? Now you have been asked only the power per circle, so you have to multiply this is into pi r square, and r is given, radius has been given as 1, so the answer will be 27 into 10 to the power minus 3 into pi. So the corresponding value, that is p. So 10 cube p by pi will simply be 27. This is the answer. Moving to the next question, that are given as alpha particle, some rest mass energy has been given. So it's some pure calculation. You can use the formula of the alpha particle's kinetic energy, that is E alpha is equal to Q into Q into 1 by 1 plus m alpha by m1, where m alpha is the mass of the alpha particle and m1 is the mass of the residual nucleus. That means in our problem Q is m minus m alpha minus m1, where m is the total the initial or the atom that which is decaying. That is am here. Here m has been given as 224.544 minus m alpha has been given as 3.728, and m1 has been given to be uranium, and it is 220.811. So what will be the Q value? You can calculate it easily. So let's do it. 224.544 minus 3.728 minus 220.811. It is 0.005. And what is then E alpha? Is 0.005 by 1 plus m alpha, that is 3.728 by m1, 220.811. So what will be it? Let's calculate. It is 0.005 by 1 plus 3.728 sorry 0.728 by 220.811. It is 0.0169. That is now equal to 0.005 by 1.0169. It is 0.0049. So that should be the answer. But it's a bit suspicious answer because usually you don't get okay, so they has been asked, okay, so the answer has been asked in MEV per c square. Okay, now it's clear. Sorry for that. So that these masses are given in GeV, right? So this is GeV. This is GeV per c square. If you want to go to the MEV, so what is the relation between GeV and MEV? I also don't remember. So let's see. Okay, so it is 10 cube. So okay, so if it is 1 GeV is equal to 10 cube MEV. Okay, so now we can make this. We have to make it this calculation a lot better. So let's see what can we do. 1 point. So okay. So answer will that comes out is around 4.91 MeV per c square. Okay, so you can add 1 here. So this will be the answer. So usually in this kind of problem, as they have asked in the questions that give answers up to 2 decimal places. So what you can do is what they usually do in answer keys is that they provide a range, like they must be they must be providing range between 9 from 0.89 to like 93 etc. They should provide range like this, and your answer will be correct if you have answer in between this range. Okay, so that's what I think. So let's move forward to the next question. 63. That six identical particles and spin-off have been asked to find the probability of two configuration occurring. So each of the T 4, 5, 6, each of them has plus minus plus mu or minus mu. Now P is the probability that this whole magnetic moment is 2 mu B. When magnetic moment will be 2 mu B of the whole system, when it is plus minus mu of 6 1, it is when the distribution of them is 4 and 2. Like 4 of them, 4 of them are upward and 4 of them are downward, right? Now, so what is the total number of possible configuration of this system? It is 2 to the power 6. Now, how many ways you can choose 4 spins? It is 6C4. And um, now these 4 spins that you have chosen, that can take either, 4 of them can take either plus mu or minus mu, but in question it has been asked that the net magnetic moment of the is plus 2 mu v. So now then there has been extra probability of factor half, that it will take plus mu only, right? So what will the answer then? So let's leave it like that. And Q is that all of them has net magnetic moment of 6 mu b, like all of them are up. So when all of them are, what are the number of ways that is like, what are the number of ways that when the magnetic moment is 6 mu b? It is only one, right? Apart, when all of them are up. Apart from that, no configuration is going to give 6 mu b. So it is one only. So P by Q, that is P by Q is 6C4 into half. Now 6C4 is equal to 6 into 4 in 6, sorry, 6 into 5 into 4 factorial by 4 factorial into 2 factorial, right? 3 into so it is 6 into 5 by 2. Now so it will be like 30 by 4. So the value should be close to 7 um, mm, 7 to 8 should be the value. So I am not sure why am I not getting an integer. So okay, so okay, so I think this should 7 or 8. It should be the answer. I am not sure though what why it is not coming to be exact integer. But let me know in the comment section that what answer did you get, or did I make any mistake. But this is the way that I think this should occur. So this is the answer according to me, 7 or 8. Okay, so let's see you in the next video. Till then, tata.